Last time, we learned some important conceptual ideas behind classes and objects. In this lecture, we'll start learning how to apply those ideas in C#. Before we can use a class or objects of a class, we need to understand what that class looks like. We need to understand information about the constructor or constructors for the class. We need to understand the properties and methods for the class, and we learn all those things by reading the documentation about the class. Before we can interact with an object at all, we need to create an instance of the object. We need to instantiate the object, and we do that using the constructor. Let's go take a look at the documentation for a deck class that I wrote. So here's some documentation from a class that I developed. The deck class is not defined in C# or Unity. It's a custom class that I wrote myself, and then I generated this documentation for it. So if you were actually using this class in one of your programs, you'd actually have to have the source code or a DLL, but we won't worry about that for this particular class. So this is custom. It doesn't just come in C#. Okay, so here's some documentation, and it talks about constructors and properties and methods. And because this lecture is focused on instantiating an object, what we care about is the constructor. So to find more information about the constructor, we click that link in the documentation, and we get to this page that tells us that we have this constructor, and the important piece here is right here with these parentheses. And so the fact that there's nothing between these parentheses means that when we call the constructor, we don't have to provide any information to the constructor. So we don't have to tell the constructor how many cards we want in the deck or what kinds of cards we want in the deck. We just call the constructor and it returns a deck object to us. Now that we understand how the deck constructor works, let's go use that constructor in some C# code to create a deck object. All we're going to do in this lecture is we'll declare and print a deck of cards. So the first thing we want to do is we want to declare a variable that will hold a deck object. We do this the same way that we've declared variables of the value types. So the first thing we put is the name of the data type. For classes, the name of the data type for the variable that will hold an object of that class is the class name. And that is, in our case, deck. Now you'll notice that IntelliSense didn't help us at all here because it doesn't know about the deck class. And that's because we don't have a deck class file here in this Visual Studio project. We will learn later how to actually add a DLL, a dynamic linked library, so we can use that class without actually having the source code here in our project, but that's for a later day. So what we want to do right now is we want to add files that define the classes that we want to use. The way we can do that is we can add them to the same folder as the program.cs for this project. So I'm going to go do that. And as you can see, now that I've done that, over here in the Solution Explorer, you can see I've added those files. And you can also see that deck is now color-coded with that blue color that we actually see for classes. The next thing I need to put is the name of my variable, and I'll call it deck with a lowercase. I would, in fact, tab to accept all of this, but I want to show you what happens if I don't actually call the constructor. So I'll just say deck, and now I'm going to try to print the deck of cards. We can use the documentation to find the method that we want to call, but I actually know that it's deck.print. And as you can see, the IntelliSense is helping us. With a method, we put open and close parentheses, and it turns out that this looks a little different from our method calls in the past. In the past, we've put a class name here, like console or mathf, instead of actually putting a variable name, like deck. That's because in the past, we've been using things called static methods. And remember when I talked about the documentation for static methods, I said we call static methods by putting the class name followed by a dot followed by the method name. The print method isn't actually a static method, it's an instance method. So we call this method by putting the name of a variable holding an object followed by dot. You'll notice we're getting red squigglies here. And the error message says we have use of an unassigned local variable dec. And that's telling us that because we didn't call the constructor, we don't actually have a dec object, so we can't call a method on that object. So now I'll go back and accept that suggestion that we call the constructor when we declare the variable. And the way we call a constructor is we put the keyword new because we're creating a new object, and we put the name of the constructor, which is always the name of the class we're constructing. And remember, we looked at the documentation and determined that we didn't need to provide any information when we called the constructor. The constructor doesn't have any parameters, so here when we call it, we don't have to provide any arguments. Now my code will compile fine and will run fine. And as you can see, I get the deck of cards. I'll scroll up. So we go all the way from the ace of clubs up to the king of spades. And that's how we can call a constructor to create a new deck object. To recap, in this lecture you learned how to use a constructor to create a new deck object.